Hi guys, today we're gonna learn chapter 9 from Form 1 syllabus. So it's prepared by me, Masturah, and Siti Fauzana. In this chapter, we're gonna learn about 9 elements, the system and structure of Earth, 9.2 composition of the Earth, 9.3 universal process of the Earth, 9.4 geohazard phenomena, 9.5 Age of Earth, 9.6 Earth Resource and Applied Geology. So first up, we're going to start from Sophia.
So for the first one, we will learn about the system and structure of the Earth, 9.1. So we want to learn about the system of the Earth. For the number one is the hydrosphere. Hydrosphere is the total amount of water on our Earth. Zone of all water on Earth, including river, lakes, sea, underground water, and water vapor in the atmosphere. The balance of components in hydrosphere depends on the natural water cycle. So for the number two is the atmosphere. Atmosphere is a layer of gases surrounding our planet. Zone of the mixture of gas that surround the Earth. The composition of gases are 78% nitrogen, 21% oxygen, and 1% carbon dioxide in the gas and water vapor. Number three is a geosphere. Geosphere is the portion of the Earth system that include the Earth interior, rocks and minerals, and the landform. Zone of the solid portion of the Earth which is made up of rocks and minerals. The geosphere develops a layer of soil in which nutrients become accessible to living organisms and thus provide an important natural habitat and the source of many forms of life. So the last one is the biosphere. Biosphere is the global ecosystem composed of living organisms. Zone of all living organisms on Earth, including those on the land, in the water, and in the air. Type of the organism that exist are related with the characteristic of the environment. We go to the next one. So for the next one, we will learn about atmospheric stratification. So for the first layer is the exosphere. Exosphere is the uppermost region of Earth's atmosphere as it gradually fed into the vacuum of space. Composed mainly of light gases such as helium and hydrogen. Location of communication satellite that orbit the Earth allows the phone call and television channel to be received. So the second layer is the thermosphere. Thermosphere is also known as ionosphere as the layer contains the ions that reflect the radio wave. Aurora, the colorful light bands formed from the action of charged particles with magnetic fields on Earth and atmospheric gases. The third layer is mesosphere. Mesosphere is the highest layer of the atmosphere in which the gases are all mixed up rather than being layered by their mass. So the fourth layer is there are no storm or turbulence here to mix up the air. So cool, heavy air is at the bottom and warm light is at the top. So the last layer but not least is troposphere. Troposphere is the lowest layer of Earth's atmosphere and site of all weather on Earth. So we go to the next one. So for this one, we're gonna learn about ocean stratification. So for the number one is a surface zone. It's known as the epipelagic zone and extends from the surface to 200 meters and 656 feet. Surface zone allows the penetration of sunlight. Thus, this zone allows the natural habitat for aquatic plants. So the second one is the midnight zone. It's called the bathypelagic zone. This zone extends from 1,000 meter, 3,281 feet, down to 4,000 meter and 13,124 feet. Has little or no sunlight, aquatic plants cannot live in this zone. The depths of water become more suitable for big aquatic animals such as giant octopus and other species of whale. And the last one is the dark zone. It's called the episopelagic zone, also known as abyssal zone. It extends for 4,000 meter, 13,124 feet to 6,000 meter, 19,686 feet. It's very dark and has no sunlight. The animal living in this zone has shiny or dazzling part of body. So we go to the next one. So for this one, we're gonna learn about water cycle. Number one is move the cloud to the atmosphere. The accumulation of cloud leads to the formation of rain. Snow is formed when there is low temperature and the vapor in the atmosphere turns in the form of tiny ice crystals. Number two is a glacier. It's a mass of ice formed from snow falling and accumulating over the years and moving very slowly on high mountains. Water is soaked into the ground and flow below it on enrich the minerals. Water also penetrates the earth crust and come out as volcanic steam under the sea. Waters flow from above as runoff and form a river. Plants take up water from the ground and transpire back into the air. The seawater contains about 97% of water on Earth. The seawater evaporates into the air during the day. Heat from the sun changes water into the vapor. Water vapor rise and condense as a cloud. The water cycle is repeated again. So that's how the water recycle occurs. So for the next one, we'll learn about the Earth, the structure of the Earth. So for the first layer and the upper layer is the Earth crust. Land is made of continental crust, made mostly from a rock called granite. The layer beneath the ocean bed is made of oceanic crust, made mainly from a rock called basalt. For the second one is mantle. Mantle we have two, upper mantle and lower. So the upper mantle is up to 670 km below the Earth's surface. The lower part of the upper mantle is made from both solid and melted rock, a liquid, while the rock is upper region is stiffer because it's cooler. So the lower mantle is between 670 km and 6,890 km below the surface and is made from solid rock. The rock is hot enough to melt, but is solid because of the pressure pushing down on it. So we have to the next one is a core. So it's the same like mantle, they have outer and inner core. So for the outer core is liquid layer of iron and nickel is 5,150 km deep. The outer core flows around the center of the Earth, and the movement of the metals creates our planet's magnetic field. So for the last one is inner core. Inner core is a mainly of iron. The temperature of the ball is 5,000 Celsius to 6,000 Celsius. That's up to 6,000 times hotter than our atmosphere. The metal that at the inner core stays solid because of the incredible pressure surrounding it. So, for the chapter 9.2, I will proceed to Siti. So, let's go, Siti.
Hey guys, so I'm gonna conduct this presentation from 9.2 to 9.3. So today we're gonna learn about composition of the earth in 9.2. So let's proceed. So earth crust is formed from various types of rocks which differ in color, structure, texture, and the way it is formed. Generally, the rocks can be categorized into three groups, which are what we're gonna learn after this. So each type of the rock forms differently and takes thousands of years to form. So let's proceed. Okay, so we're gonna learn about types and characteristics of rock. There are three types of rock, which are igneous rock, sedimentary rock, and metamorphic rock. So igneous rock is formed from the process of cooling and freezing of magma or lava that flows out of the mantle. These rocks were once liquid magma that erupted from volcanoes. They cooled very quickly, which is why the crystals are usually very small. So the example of igneous rock is basalt and granite. It contains various of mineral. Next is sedimentary rock. Sedimentary rock formed by compression of deposit material carried by the river, glaciers, and wind. These rocks formed when loose sediment, rocks, and sand were deposited by water, compacted, and cemented together. These rocks form along beaches by river or under the water in the lake or oceans. Examples of sedimentary rock are sandstone and shale. It consists of many layers which are sometimes hollow and contains fossils. Next is metamorphic rock. Metamorphic rock formed when igneous rock or sedimentary rocks are exposed to very high pressure and temperature. This usually happens during the mountain building event, regional metamorphism, but also happen during igneous activity. So, example of metamorphic rock is quartzite and slate. Usually, metamorphic rock is harder than the original rock that formed them. So when sedimentary rock or igneous rock are exposed to very high temperature, then they will form metamorphic rock. So let's proceed.
Have you ever wondered where rocks with so many different colors and textures come from?
So these are the video about the process of the formation,
which features three types of rocks: igneous, sedimentary, and metamorphic, which can all change into one another. Igneous rock forms when magma or lava cools and hardens. I am an igneous rock. I'm a volcano, and I can form amazing structures as I cool, shrink, and solidify into rock. The buildup of contraction forces causes patterned cracking, which can form beautiful columnar basalts. Look here I am, eroded by a waterfall. Erosion happens when surface processes break down rocks and move them to new locations. Here I go! Rocks can be transported by wind, water, and ice. I'm joining some other rocks going along this river. As we go, we tumble and get smoother and rounder. We also get sorted by our size. The larger sediments like gravel don't get very far, but smaller sediments can be carried further. Sand gets a bit further than gravel, and tiny clay particles go all the way out to the ocean. Sedimentary rocks are formed when products of erosion and other particles accumulate and are subsequently cemented together. Someday, I might become a fragment in a type of sedimentary rock called a conglomerate, which has large rounded fragments with smaller sediments, all cemented together by calcite or quartz.
Sediments near the ocean shore come largely from eroded shore sediments like clay, while those far from the ocean shore often come from dead organisms. I am a sediment who lives at the bottom of the North Atlantic Ocean. Long ago, I was a fragment of a tiny shelled organism called a coccolithophore. As we get buried, we ocean floor sediments get compacted and cemented together. Cement fills in the spaces around the sediments with precipitated minerals, binding them together to form rock. After being buried, compacted, and cemented, I've become part of a sedimentary rock called limestone. I live near a subduction zone, a region where pieces of the Earth's crust called tectonic plates collide, and one goes under the other. As I get closer to the hot core at the center of the planet, I undergo metamorphism and recrystallize to form marble, which is a type of metamorphic rock. Metamorphic rocks are formed thanks to temperature and pressure changes inside the Earth. Different metamorphic rocks form from different parent rocks. For example, sandstone exposed to heat and pressure can become quartzite, but if my friend basalt were exposed to heat and pressure, she could turn into greenstone. After burial, partial melting of the rock can occur, forming magma, the raw material from which new igneous rocks are formed, and the rock cycle continues.
So I hope you guys can understand better about the video. So let's learn 9.3, the main process of the Earth. Let's proceed. So in 9.3, we're just going to learn about exogenous process and endogenic process. So exogenous process is a process that occurs on the Earth's surface. We have weathering, mesoland depletion, transport and sedimentation, and also erosion. For weathering, it's a process of rock fragmentation and decomposition, or decay due to changes in temperature, rainwater, bursting, and microorganisms. Mesoland depletion involves soil movement from the top of a slope to below as a result of gravitational force. Next, transport and sedimentation. Weather corroded materials are moved by agents such as running water, wind, waves, and glaciers. The material will be sedimented when the velocity of the agent decreases. For erosion, a process of eroding of the Earth's surface by moving agents such as wind, water, and waves. So let's proceed to endogenic process. So endogenic process is a process that is caused by force from within the Earth or in the interior of the Earth. We have mantle convection process, Earth crust movement, and also magma activity. For mantle convection process, the high temperature in the mantle in the core of the Earth produces convection current in the asthenosphere layer. These currents are able to move Earth crust. So as you guys can see in the picture, the asthenosphere layer. Next, let's move to the Earth crust movement. According to the theory of plate tectonics, the Earth crust is divided into several pieces of plates. These plates constantly move, resulting in collisions in divergence, which produce various landforms on Earth and continental drift. Magma activity. Volcano on the Earth crust that allows molten and hot magma to flow out through it in a strong eruption. The eruptive material accumulates around the slope of the vent and form volcanic cones. So let's proceed. That is just you. In this chapter, you just need to learn about endogenic process and exogenic process. I hope all of you guys can understand. So let's proceed with Masturah. Thank you.
So for the 9.4, we will learn about the geohazard phenomena. So let's go. So the first geohazard phenomena is the volcanoes. Volcano is a rock in a metal will melt and become liquid rock or magma under very high pressure and temperature. So the magma is less dense and it rises above the solid rocks and it's stored in the magma chamber. So the convection of magma produces greater pressure and endogenic energy in the magma chamber. Volcanism releases a lot of ash, magma, carbon dioxide, steam and heat. So the magma that flew out cools on the Earth's surface and become a lava. So that's how volcano occurs. So let's go to the next one. So for the second one is a tsunami. Tsunami is occur maybe caused by earthquake or volcanism in the ocean floors. So this is how tsunami occur. This is the anatomy of a tsunami. So the tsunami form when an earthquake vertically shifts the seabed by several meters, displacing hundreds of kilometers of seawater. Large waves began rippling across the ocean away from the earthquake epicenter. And in a deep water, the tsunami moved at speed of up to 800 km per hour. When it approached shallower coastal areas, it slowed down but increased the impact. So, tsunami in Japan means harbor wave. Let's go to the next one. So, this is an earthquake. Earthquake is the shaking of the ground caused by sudden collision, friction, or the separation of tectonic plates along fault lines. So this is how earthquakes occur. Massive vibrations in the ground are produced by strong endogenic energy in the earth crust. Its release travels from the epicenter in a direction in the form of seismic wave. Seismic wave can be detected by a seismometer. The magnitude of an earthquake is the strongest at the epicenter of the Earth's surface. So, if you look at that image, so that's how earthquake is occurring. So let's go to the next one. So, if you guys don't know, seismic wave is the radiate from the focus of an earthquake. So, this is a quicksand. Quicksand is happen when the saturated soil friction and become mushy. The soil is unstable and can no longer support weight. So this one is a sinkhole. Sinkhole is where it occurs is sediment fall into a cavity. So a spelling continues the cohesive covering sediment from a structural edge. The cavity migrates outwards by progressive roof collapse. The cavity eventually breaks the ground surface, creating sudden and dramatic sinkhole. So that's how sinkhole is occur. So for the next one, I will show you a video about a science and technology used to prepare for the geohazard.
Hey guys, welcome back to the Earth series. In this video, we are going to talk about geohazard phenomena. Usually when this geohazard happens, we need to be prepared. These geohazards are environmental disasters that cannot be avoided by us humans. The application of geoscience can help us prepare for the possibilities of geohazard and minimize their impact to us humans. First, we have the earthquake technologies. Now, these technologies have two types, which is the seismometer, or also known as seismograph. And second, we have shock observer. Let's start with seismometer. Seismometer is a device that detects and measures the magnitude of seismic waves of an earthquake. A record of seismic waves measured by a seismometer is called a seismogram. A seismologist analyzes a seismogram to identify the strength of an earthquake and to predict an earthquake. Again, we have the shock observer. As you can see in the picture below, this is what a shock observer looks like. It's a device that acts as a cushion to absorb and reduce vibration from the ground. It's mainly used to protect buildings and bridges from cracking and damage under strong vibrations. Next, we have the tsunami technologies, tsunami meter and tsunami buoy. This technology is to measure water pressure in the oceans to detect movement of tsunami waves in the ocean. Its signal recorded by the tsunami meter will be transmitted by a tsunami buoy to onshore tsunami operation centers through satellite. Next, we have the landslide technologies. We have LiDAR detection and reading, or LiDAR, and satellite and global positioning system, also known as GPS. Now, when this geohazard phenomena happens, there's a huge impact on our lives, and it's usually negative. For example, we have great loss of lives, loss of home and property, cause extensive damage to public infrastructure, cause starvation and famine due to the food scarcity, spread of infectious disease due to the improper sanitary systems, and even psychological issues such as post-traumatic stress disorder. During this kind of time, there are various help and contributions that can be provided. First, we have donating money to charitable organizations. Second, we have contributing energy and expertise to redevelop the affected community. Third, we have offering medical resources such as healthcare services and even blood supplies. Fourth, we have donating essential items such as food, water, and even clothing. And last, providing moral support and counseling services. That's all for today. Thank you for watching. Be sure to subscribe, and since you're still here, why not follow me on my
So I hope you guys understand, and that's all from me. So thank you. So I will proceed to my friend Masturah.
Hi, so today I'm going to conduct about age of Earth 9.5. So basically, this chapter is just going to be talking about what is Earth. So, how old is Earth? Earth is 12.543 billion years. As you can see, this table is called geological time scale. Era is made a limited duration of time that the duration of an eon itself subdivided into periods. This is the period an animal is extinct to extinct for a very millions of years ago. Next up, we're going to see about what is fossil. Fossils are Earth's materials such as plants, animals, and insects which have been submerged and buried for a very long period of time. Examples include bones, shells, skeletons, stones, imprints of animal or microbial objects preserved in amber, hair, factory wood, or coal energy units. So you see what are
Hey, buddy.
how they are.
What's up? Oh, you have an assignment on fossils. Let's learn about fossils today. Fossil is the word we use to describe a wide range of natural artifacts. It is the preserved remains of a living organism, such as a plant, insect, or an animal. The word fossil comes from the Latin word fossils, meaning obtaining by digging. Fossils are very important for us if we want to know what happened before us or before our time. The scientists who specialize in studying fossils are called paleontologists. Let's learn about types of fossils. Trace fossils. What happens when you step in mud?
That little more.
Millions of years ago, when dinosaurs roamed the earth, they also made large footprints. Fossilized footprints are called trace fossils because they were made by the activity of the dinosaurs. Footprints can tell about the size of the animal, number of legs they had, how they moved, and how fast they could run. Ancient fossilized homes of animals tell us about how and where ancient animals lived. Any fossil that explains the activity of ancient creatures is a trace fossil. Examples: burrows, borings, footprints, and root cavities. Mold fossils. Mold fossils are fossils formed when a plant or animal dies and is covered by sediment. Its flesh decays with time and bones deteriorate, and it leaves a cavity below the ground surface. Cast fossils. It is formed when the formed mold fossil is filled in by surrounding minerals and sediment. It is a replica of the original organism and provides an impression of the original structure. True form fossils. These are large body parts of an organism that has been replaced by minerals. It's created by a process known as petrification. The word petrified means turning into stone. These types of fossils form when minerals replace all or part of an organism. Examples: limbs, torsos, and heads. Let's see the importance of fossils. Fossil remains can give us an idea about how ancient animals and plants obtained food, reproduced, and how they behaved. Coal, gas, and oil are called fossil fuels because they're formed from the organic remains of prehistoric organisms. They are abundant and accessible, and they provide a huge amount of concentrated energy. It helps us to know about the Earth's history. Geologists gather information from fossils, and it can be used to understand when different layers of rock were formed. Now, you know a lot about fossils.
So that's all from the video. So in here we know how fossils are formed. As you see in the video, they have stated the importance of fossils to current scientific development and describing it that. So fossil is important to record can provide information about how animals and plant species on Earth have evolved over millions of years. Fossils also record can also provide information about species that gone extinct. Is this a recap about various of organisms of Earth since 5,000 million years ago, from the original of Earth to dinosaurs with protozoa and to here. The next step we're going to learn about 9.6, Earth's resource and applied geology. So in this chapter, we're going to see the differences between surface water and underground water. Surface water. Surface water is the water located on top of Earth's surface, such as rivers, creeks, wetlands, even oceans, and such if any water is on the surface. And about the underground water. Underground water or aquifer fills up the empty spaces between soil particles and the layer of movable rocks. You can find underground water when you dig in somewhere in mud, so you can see the water, so that is called underground water, or you have to see in the picture that is shown in front. What are the effects of surface water and underground water when it's polluted? So the effect is, for the surface water can be polluted by waste material from industrial and housing areas. Excessive fertilizers and pesticides from agriculture areas also pollute river water. If we throw any rubbish on them or just making them dirty, it can cause a lot of diseases and so on to humans and also flora, fauna that live in water. Underground water. Underground water is it affects leaching of chemical fertilizer and pesticides in agriculture exposed underground water to raise the pollution. Chemicals from industrial and domestic waste in landfills carry the risk of polluting underground water. The pesticide we use in agriculture can expose the underground water and it can may pollute the underground water. After the underground and surface, we're gonna learn about the economical minerals. So, economical minerals in Earth consists of three parts, which is metallic minerals, non-metallic minerals, and rare earth minerals. We're gonna see the examples of metallic minerals first up. Metallic mineral, the example is iron ore, copper ore, gold ore. We can use these metallic minerals to do the vehicles, electrical wires, and jewelry. For the electrical wires, if you just cut the wires, you can see the middle part with copper. So that's where what is the uses of copper. For jewelry, we use gold as our jewelry. For non-metallic minerals, the things are called petroleum diamonds. The uses is to do jewelry, cooking, and lubricants. For the rare earth minerals, yttrium, platinum, helium. There's 14 more examples of rare earth minerals. There's 17. So the uses of rare earth material is to do computer, electronics, and DVDs, and so on in electric appliance. Of petroleum and natural gas.
Formation of petroleum. Let us study the formation of petroleum. Petroleum was formed from organisms living in the sea. It was formed by a complex process. As these organisms died, their bodies settled at the bottom of the sea and got covered with layers of sand and clay. Over millions of years, absence of air, high temperature, and high pressure transformed the dead organism into petroleum and natural gas. Petroleum layer is formed above the underground water layer, as it is lighter than water. Petroleum is a non-renewable resource and is used on a very large scale. The world's first oil well was drilled in Pennsylvania, USA in 1859. About 8 years later, that is, in 1867, oil was found at Makkum in Assam. In India, oil is also found in Gujarat, Mumbai, and in the basins of Godavari and Krishna.
So next up, we're going to see the formation of coal.
Millions of years ago, the earth used to be covered by trees and plants. These plants died in swamps around riverbanks and got covered with soil and mud. As the years passed, the weight of the ground along with the earth's heat converted these dead plants into coal. To extract coal, it needs to be dug out. Coal is usually found in layers or seams underground. As plants die, they sink into swamps and get decomposed into peat. Ground heat and pressure remove hydrogen, oxygen, and nitrogen from it to leave mostly carbon. This is what we know as coal. Coal is classified by its carbon content. The greater the carbon content, the more heat it gives off when burnt.
So that's all about the formation of coal. And next up, we're going to see what is hydrothermal. Before we see what is hydrothermal, we're going to see, have you ever been to hot spring, or do you know why the water is hot in the hot spring? So here it is. Hydrothermal process is the water heated naturally by the heat from earth, known as hydrothermal process. As you can see in the picture, the heat source, which is magma, will heat the metamorphic rocks, and next it will heat the aquifer, and if the water in the upper layer in the heated aquifer will become hot, and it will form the hot spring, the hot water. And you can also use the hot spring to electricity generators too, and the hot steam is used to run turbine and generate electricity. We're gonna see about a video for hydrothermal.
Peter and his sister Jane are having a splashing time at the hot springs park. There are several pools with different degrees of hotness. Some pools have water vapors rising up from the surface. Peter and Jane are playing in a pool whose water is warm and just right. Their mom puts several eggs into a woven basket and lowers it into a pool whose water is hot as a lot of steam is rising up from the surface. After about 10 minutes, she takes out the basket of eggs. Their mom then gingerly picks up one egg, cracks it, and peels off the shell and passes the hard-boiled egg to Jane. Peter is amazed that the egg can be cooked without any fire. Back home from the hot springs, Peter surfs the internet as he is curious as to why the water is naturally hot. He discovers that the water at the hot springs obtains its heat from the Earth's interior. The Earth can be divided into layers based on its physical state. The outermost layer, called the crust, is a solid. Below the crust is the mantle, which is a liquid of molten magma. The inner core is also a solid and is the hottest. The liquid magma is heated by the hot core and rises to the surface below the solid crust by convection. There, it transfers its heat to underground water in the Earth's crust, cools down, and sinks towards the core, where it is heated up again. This continuous circulation of magma, due to convection currents, heats up the underground water, some of which escapes onto the Earth's surface as hot springs or geysers.
What the?
So that's for how the hydrothermal process goes. So the negative effect of unplanned human activities. The causes are deforestation, agriculture, industrialization, open burning can affect the earth by erosion, flash flood, extinction of flora and fauna, global warming, and more negative effects. So that's all for me. Thank you.
So guys, I hope you guys enjoy watching the video, and I hope you guys understand how we explain to you guys. So as usual, don't forget to subscribe, like, share, and comment for this video. So, thank you for my friend Masturah and Siti for explain to all people that would love to see this. Okay, so I will see you guys next time. Bye.
Thank you. That's all for me.
Okay, very good, huh? This group done very good job. Okay.
Can you repeat again?
Hi. 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 Kita naman.
Congratulations, guys! You did a great job.
Yeah, so nervous
Yes,
sa
you guys. So you guys are
example
awesome,
lagi na.
guys.
My God.
Okay lah. Okay, nak join DM. My
Okay,
okay,
bye.
Bye. Good, Tanya. Bye-bye.
Shining starting and gitu. Jangan lupa subscribe guys.